All right, so let's go ahead and get started. Now you guys are comfortable, have plenty of elbow room. Feel free to lay down. Take more than one chair. I think there's plenty of space. So let's go ahead and get started. My name is Michael Washam. I'm a principal cloud architect for Aditi. I used to be on the Windows Azure runtime team. I was a program manager for the PowerShell Cmdlets. Before that, I was on the evangelism team for infrastructure service. And before that, I did lots of consulting work within Microsoft. So mandatory plug from my employer. We're a consulting company. We do lots of really cool cloud stuff. If you need any help, let us know. Now, Windows Azure PowerShell. Before we get started, how many of you use regular PowerShell to automate Windows today? Okay. How many of you use Windows Azure PowerShell Cmdlets so far? A few? Okay. How many of you use Windows Azure? All right. So you guys are the people that are clicking through the portal and everything, having to do things the hard way. Okay. So the PowerShell Cmdlets, you can do a lot of powerful, nifty things with them. From an automation perspective, which is obviously the key goal of PowerShell, you can query, you can manage, you can configure pretty much every Windows Azure resource there is. Virtual machines, cloud services, Windows Azure websites, storage. You can upload blobs. This is some recently new stuff, so if you haven't used PowerShell Cmdlets in a while, take a look. You can create queues, databases, Windows Azure SQL databases fully supported. And the real benefit is you can do this across multiple subscriptions. Maybe not everyone runs into this problem, but me being in consulting or doing a lot of conferences, I have a lot of different subscriptions to manage. So being able to write a single script that I can iterate through all my subscriptions and do things against is really powerful. The next thing, if you're doing infrastructure as a service particularly, is really critical. You can use PowerShell to provision a fully composed virtual machine. And what that really means, this may not sound that important to you until you go try to spin up 50 virtual machines, is as you've seen in the portal, I can create a virtual machine, walk through, configure it, and boot it up. And once it's created, I can then go back and add a data disk, or I can go back and add a network endpoint. Or I can change my disk cache settings. But what if I want to do all that stuff, times 50, or times 25, or times even 5? Going through and configuring each virtual machine one step at a time to the portal is great for a single VM, but for doing it for a bigger deployment, it's really a painful process. And from PowerShell, I can create the virtual machine configuration exactly how I want it one time, and I can multiply that times however many virtual machines I need. A good example is domain joining a VM. So if I wanted to deploy, say, a SharePoint farm, right? So SharePoint farm takes anywhere from 2 to 10 to 20 servers. Booting all of those up and then logging into each one of them individually to log in and domain join is kind of painful. PowerShell, I can have it booted up and do domain join at boot time. So I do that one line of code and it's done. Something new, I'm going to have to eventually take this new out. But a couple of months ago, we added the ability for remote PowerShell by default with virtual machines. So whenever you create a virtual machine for PowerShell or the portal, remote PowerShell is now on by default. You can turn that off, of course, if you don't want remote PowerShell turned on. Just be warned, it is a provision time setting. You can't automatically go back and turn it on later if you don't turn it on in the first place. From a networking stack, using PowerShell, I can define my entire virtual network settings for my Windows Azure subscription. I can set my DNS servers. I can create my VPN gateways. I can do all of that. The only thing it doesn't do yet is it doesn't do the point-to-site gateway work. I think they're working on that coming soon, but the site-to-site virtual networking is fully automatable from PowerShell. And a very brand new feature that was literally just come out beginning of June is the ability to set access control lists on public endpoints. So a common pattern in Windows Azure is to expose a service on a virtual machine and consume it from a different service. This could be, say, a Windows Azure website or a mobile service, or it could even be a service somewhere off in it could be a service in Amazon, for instance. And the ability, or what you didn't have before, was the ability to lock down who could actually access that endpoint. Pretty much it was open to anyone. So the ability to lock down endpoints, so only this server or this set of servers can access your endpoint, is really critical from a security perspective. The last thing I want to mention is storage. Dealing with infrastructure servers especially is extremely important. The ability to upload and download VHDs. So take a virtual machine from your on-premises network, upload it to the cloud, boot off of it, and vice versa. If you create a virtual machine in the cloud and you want to run it on-prem, using PowerShell, it's really easy to download that VHD and run it in your local hypervisor. So getting started, this is, owning the PowerShell commandlets for such a long time, this is probably the most common complaint from users. It's kind of a pain to get it set up and configured. So I wrote a little slide here just to kind of give you the crash course on how to make it work. The first thing you need to do, besides actually having a Windows Azure subscription, is go to windowsazure.com, click Downloads, and install the Windows Azure PowerShell commandlets. From there, you have to import the PowerShell module. So you have two options here. If you install the PowerShell commandlets and reboot, it's real simple. You type in import module Azure, and it works. If you don't want to reboot, you have to import using the really long, funky path to the azure.psd1 file. Once you reboot, you never have to do that path again. Once you've imported the module, then you need to run a commandlet called get Azure publish settings file. What this guy does is it does some really powerful work of basically all it does is really launch IE and take you to a web page. So it really doesn't do anything fancy except it magically knows the URL to take you to the right page so you don't have to remember it. And also we may change it in the future, so this commandlet works out well for that. So you run get Azure publish settings files. It allows you to log in using your Azure subscription and download a configuration file that has all your subscription information in it. And you only have to do that one time unless you are have new subscriptions that you're an administrator of. So basically you need to do it once per every time you update your subscription settings. So once you've downloaded that file, you do import Azure publish settings file, and it sets up your local configuration. And what it does is it basically, inside the publish settings file, there's a certificate that's installed in your Azure subscription, and it installs it on your local machine. And you don't have to do these ever again on that laptop or desktop or whatever you're running on. If you want to run it on a different machine, you do. But to configure your one machine, you only have to run those one time. And from there, there's various commandlets to actually manage your subscription. So there's a current storage count property that's really important. Whenever you're creating virtual machines, it wants to know what the current storage count to use for storing virtual hard disks is. You can override that and tell it exactly which one to use, or you can just set this once, and every commandlet from then on will either look for VHDs or create them in the storage count. So let me just jump into a real quick demo to show you how this works. Okay, so here's the Windows Azure homepage. If you were to download PowerShell commandlets, you'd click on Downloads, Command Line Tools, and scroll down to the very bottom. And note, we're at a Microsoft conference for a PowerShell session, so I would download those. But if you also happen to be one of those people that likes to automate stuff from your Mac or your Linux device, we do have cross-platform command line tools that run natively on Mac and Linux, and they're all written in Node.js. Very, very great command line tools as well. So the first thing you'd do is you'd run the PowerShell install, click Run, walk to the web platform installer wizard, and once you're there, you're done. And there's various PowerShell editors you can use, but the one that I use mostly is a PowerShell ISE. So PowerShell ISE. So once you've installed, you want to run this to make sure all the commandlets are loaded. And I'll show you this great, powerful IE automation tool. Run get Azure publish settings files, and it'll kick off the browser and take you to this magical URL, which you'll never remember, and you need to log in with your user profile. So I can say, and one thing to keep in mind is what this will do is every subscription that you're an administrator of or co-admin of, it will actually generate a management certificate in each one of those. So be careful about how many times you use this. This is why I say once, because you have a limit of 25 management certs per subscription. So you can reuse this file though. So if you use it and then you want to put it on multiple machines, you can copy it to multiple machines without having to download this again. Because literally every time you hit this page, it creates a management cert in your subscription. So it's going to give you this really long file name that has the name of every subscription you're a co-admin on or an admin on. And feel free to rename that to Azure, because it's much more intelligible that way. And if you take a look at that, you don't actually need to look into this file, but if you ever wanted to, what it consists of is your subscription ID, your subscription name, and this is what matches exactly in the Windows Azure Management Portal. So if you go to the portal, you can rename your subscriptions, and it'll show up here whenever you export it. and then this big, long, giant XML or base64 encoded management cert. This is basically an X509 certificate. Whenever I run import Azure publish settings files, it's going to take this, rehydrate it to a cert, and install it in your local certificate store. Now, the next step you would do is import Azure publish settings file. You'd run that, and now your PowerShell client is, your laptop, your desktop is set up to run Windows Azure PowerShell Cmdlets. And to prove that, there's various Cmdlets out there you can use to run and see all your subscriptions that are configured. And this is actually all persisted in an XML file in your user profile. So you don't have to run those Cmdlets again. You launch PowerShell ISE again, and it's still there. So all of your settings are still there. So if you notice, I have 3 or 4 different subscriptions. I have a DD Demos and Cloud Service Practice, something or another. And how you navigate these different subscriptions is by using the Select Azure Subscription Cmdlet. This is basically how you can switch between the 3, or your subscriptions. So now, any Cmdlet I run after that is going to execute in a DD Demos context. So let's go ahead and create a virtual machine. So to create a VM, I need a couple of pieces of information. In the portal, you have to pick the data center. You have to pick the image name of what you want to base your virtual machine off of. So I'm going to call get Azure VM image, and I'm going to pick a property out of it. Actually, I'll dump the whole thing out for now, and you'll see why I filter it. So this is basically calling the REST API that the portal uses to enumerate all the images in your management portal, the platform images. Now, this will actually dump out a lot more information than the portal will. So we're calling a raw REST API. We're not filtering anything out. So it's going to give you pretty much a bunch of images that aren't even in the portal display. What I can do, though, because I don't want all that information, I really just want the image name, is I can filter out to just a property I'm interested in. So you can see the right scale images, SharePoint, SQL, Ubuntu. So let's pick, the Windows Server 2008 R2 preview image. So did everyone know that you can spin up an R2 preview image in Windows Azure today? So you don't have to download the VHD and put it in hypervisor. You can just copy and paste or walk to the portal and spin it up. So I'm going to go ahead and save that image name. And now the next thing I need is I need to know the data center location. So I can call a get Azure location cmdlet, and this will dump out all of the data centers that are currently available to your subscription. And this may vary depending on your subscription. Like if you use some of the hands-on lab ones, you might only see East Asia or whatever. My subscription, I pretty much have them all open. So I can pick West US. So I'll say location equals West US. Now I want to make a virtual machine, so I'm going to say new Azure VM config. Now what this cmdlet actually does is it doesn't create a VM, it creates a configuration object. This is what I meant earlier by a fully composed virtual machine. So I'll call this one my TechEd VM1. And I can say the instance size. You can say all the way, extra small all the way up through A7. So my quota, my subscription is pretty tiny though, so I'm going to keep everything small so I don't run out of bits. And I'll pick my image. And you can also do a couple of other nifty things here. So the media location parameter is optional. You don't have to specify this, but what it allows you to do is override the name of the VHD that is created in the location. So if you go to the portal or you just let the PowerShell cmdlets do it for you, the disks for all your virtual machines have this really complicated pattern, the date, the time it was created. If you actually just want to give it a specific name, like my AD OS disk, this is how you can do that. You can override that information here. Now, from a provisioning configuration, since I'm booting off of an image, I have to tell it what to boot up with. If I was booting from a disk, something that you've already it's already general or specific, it has machine name, administrator accounts, you wouldn't use this cmdlet. But since I'm booting off of an image, I can specify all the provisioning information. So I'm going to pick my Windows parameter set. I can specify the username, And then I need to specify the password. So I'll make some random password here. And there's a couple other nice parameters I can specify at boot time. So I can tell it to reset the password on first login. So if I set this, I could log in and immediately I'd be forced to change the password. I can tell it to disable automatic updates. I can tell it not to create the RDP endpoint, specify the time zone. I can deploy X509 certificates with it. So if I wanted the machine to boot up and have certs available already, I can enable WinRM, Remote PowerShell for HTTP, which is not on by default. It's only HTTPS that's on by default. Or I can disable HTTPS or PowerShell. So I'm going to skip most of those. Now we'll add a few other niceties here though. So I'm going to add it. I want this virtual machine to boot up and have a little bit of storage. So I'm going to add at least one data disk. I'll make it 500 gigabytes. And I'm going to put it on the first one. Now, if I wanted multiple data disks, I can put up to 16 data disks per server on an extra large and above instance size. All I'd have to do is copy and paste that commandlet. And now I have 2 data disks at 500 gigabytes each. And I could do the same thing with endpoints. So if I wanted to open up port 80, when this machine boots up, I could do that. Now, if I wanted to, so this is how you would compose a virtual machine to boot up. Now, if I wanted 10 of these, I could literally create that instead of VM1 as a single object. I could make that an array, put a for loop, and bam, I have 10 virtual machine configurations. So it's really that easy to spin up a lot of hardware. So I have my virtual machine object. Now the second task is I want to actually create the virtual machine itself. So what I just specified, dash service name, in Windows Azure Infrastructure as Service, all your virtual machines are actually contained in a container called a cloud service. Assuming everyone probably knows this already, but if not, go hit Mark Rusinovich's Windows Azure Internals talk later and it'll make more sense. But generally, you have a single public DNS name that you can nest multiple virtual machines inside of. So you put multiple virtual machines inside of this and you can reference it from the public DNS name. So, and this is a DNS host name, so it does have to be unique within the cloudapp.net. So that's why I kind of like putting characters in here just to make sure everything just works. Now, location is where I want to specify location. Oh, and I should have used my parameters over here. That's okay. And finally, I need to specify my virtual machine configuration. Now, this takes an array, so I could pass in VM1, VM2, or just an array of virtual machines. So I just have one. I'll go ahead and hit a 5, and this is going to start creating my virtual machine, assuming I didn't typo something. And that's really all it takes from PowerShell to compose a virtual machine. And that is obviously a lot of typing, a lot of things you can get wrong. But the intent of PowerShell is that this is something that you're going to reuse over and over again. You're going to create. This is going to be part of a bigger deployment that you need to automate. So while that's creating, let's jump back over to the slides here. You saw how to create a virtual machine, add data disk, add endpoints, but how do you add data disks and endpoints to one that's already running, or many that are already running? Again, whenever you're working with PowerShell on virtual machines, you're not working directly with a VM, you're working with a config. The intent is you either create the config and post it to Windows Azure, or you retrieve an existing configuration, modify it, and then post it back to Windows Azure. So from a PowerShell perspective, to do an update, you want to call get Azure VM, which is going to return back the configuration information you need. You're going to use other commandlets like add Azure Data Disk or add Azure Endpoint to modify that config, and then you call, instead of calling new Azure VM, you're going to call update Azure VM and basically post that config back to the API. Now, this is the most concise way I think you can write this, but I've heard different debates on which is more readable. I mean, I'll let you guys do whatever you want to, obviously, but this is the alternative way of writing the exact same thing. So return the VM configuration. We have a config object. You then add Azure Data Disk. You modify it by passing in the parameters. Add Azure Endpoint would modify that same config. And then update Azure VM would actually pass that configuration back to the Service Management API. So real quick example of how to do that. So our virtual machine has been created. So I'm going to pull up another page here, and I'm going to call the get Azure VM commandlet. So I have a lot of virtual machines in this deployment, so we'll just have to find the one that we're going to use. So there's the one that we just created, role state unknown. It's still booting up. You can see all the other statuses for all the other virtual machines, though. So there's a couple of get Azure VM works off two different methods. If you pass it no parameters at all, it returns every virtual machine and cloud service in your subscription. If you specify a specific cloud service, it gets a lot more granular. So I have a SharePoint farm here that I could pass a service name for. And that is going to dump out all of the virtual machine configuration for every VM in that cloud service. So you can see there's quite a bit of information here. But let's perform an update. And to do that, I just want to, we'll open up another endpoint on the VM we just created. So the name of that cloud service is MyTE Cloud Service 1A. That's the only downside of having these unique names. You have to remember them. So if I call that, that'll again return back all the virtual machines in my collection. So if I wanted to add an endpoint to every VM in the cloud service, I would just use that as a filter. If I wanted to do it only for a specific VM, I can actually give it the name of the VM, which is MyTE VM1. Oops. So now I've actually saved that information into a variable, so I can do config and dump that out. And you can see this is basically the status of current configuration of that virtual machine I just pulled back. Now what we want to do, though, we want to do an update. So I'm going to pipe that configuration out to the add Azure endpoint commandlet. And I'm going to open up some random port. So what's going on here is add Azure endpoint is modifying the return config and passing that to update Azure VM, and I'll now have port 8080 open on my local port. Now, notice I didn't specify a public port. What happens whenever you do not specify the public port is Windows Azure is going to pick one random ephemeral port that's not used, and it's going to pick it for you. So if you ever want to open up a random public port, just omit the public port and let Windows Azure figure it out for you. Okay, so let's talk a little bit about remote PowerShell. So I mentioned earlier that remote PowerShell is turned on by default. So the virtual machine we just created, we didn't pass any flags or any parameters to enable remote PowerShell, yet it actually does have an endpoint for 5986 open on it, and it's ready to go. So it is enabled by default. You don't have to do any work to make this turned on. You can, of course, disable it if you want. How the SSL is generated, though, because you notice we do everything over 5986, so it's all SSL-based. So what happens is if you do not specify a certificate, if you have your own certificate, you can pass it as a parameter, but if you don't specify one, the Windows Azure Service Management API will actually generate a self-signed certificate for you and deploy it to the virtual machine. So it is self-signed, meaning that to use it in a secure fashion, you need to take some additional steps, and I'll show you how to do that here in just a bit. So HP is optional for VM to VM in PowerShell. I can enable WinRM HP, and from there I can log into a VM in the cloud, and from there I can use remote PowerShell for all the other VMs within my cloud service. But from external to your the single VM, it's going to go over HTTPS. This is extremely useful for in-guest customization. So you wanted to boot up a virtual machine and do something with it, say install IIS or install an app or whatever, or monitor it. So you can log in and check disk space and all that good stuff. So here's some of the finer details that are available. Wait for boot's a really handy switch for new Azure VM that basically tells you to, or tells Windows Azure to not do anything with the, not return from your PowerShell script or your PowerShell commandlet until it's actually up in a roll ready state. So if you wanted to immediately launch into remote PowerShell and do something with the VM on boot, you could use this flag without having to poll for making sure that Windows is ready. Setting up the connection. As I mentioned earlier, all the virtual machines in a cloud service all share a single IP address, which means that all VMs obviously can't be listening on 5986. They're all, for remote PowerShell, they're all going to be listening on some random public port. So instead of you having to go to the portal to figure out what that random port is first before you script it, there's a commandlet added called get Azure WinRM URI that basically figures this out for you. And it basically gives you a connection string that you can then use with invoke command or enter PS session to use remote PowerShell. Now, there's one thing that you should note whenever you're using remote PowerShell is since if you let the platform do it for you, it does generate this self-signed cert. To make this secure, to make sure you're not susceptible to man-in-the-middle attacks, you need to download and install the generated cert on your client machine. And that sounds like a lot of work, and it really is. So we wrote a helper function that basically does all this for you. So you just tell it the cloud service name and the VM name. It goes and figures out what the cert is installed in the cloud, downloads it to your local machine, and you don't have to skip the certificate authority checks or anything like that. It establishes a true SSL session, so your connection is really secure. So let's walk through a real quick example of how you can use remote PowerShell in Windows Azure. So I have another VM that I booted up earlier. Actually, I should have it here in the list here. And it's called My Remote Source 1 is the name of the cloud service, and the VM is My Remote VM 1. So I'm going to get the URI for that using the get Azure WinRM URI. And I'm going to show you why get Azure WinRM URI is pretty useful. So if I wanted to connect to a remote PowerShell, I have to know what the public endpoint is. And how I could figure that out is I could launch the Windows Azure Management Portal, go under Virtual Machines, go under My Remote VM 1, Endpoints, and you can see all the different endpoints that are there. RDP, I have Web, and WinRM HTTPS. This is the remote PowerShell endpoint. And if you note, the public port is 58821. You'd either have to use Psychic Powers to figure that out, log into the portal, or use get Azure WinRM URI, and it'll figure it out for you. It basically does some grunt work for you. So if I go back and look at the output of that, it basically concatenated that string for me automatically. So now I don't have to know what that port is ahead of time. It just kind of figures it out for me. So using that, I can use just basic core Windows PowerShell commandlets to actually enter a remote PowerShell session. So I can do enter PS session and use a connection URI. And I need to use a get credential commandlet and log in with the username and password that I created earlier when I created the VM. So now I'm logged into the remote PowerShell machine. You can see down at the bottom, this is the actual host to do that. So it's pretty straightforward. The only trick is installing that WinRM cert. And let me show you what that looks like real quick. So this is the code I used to create this virtual machine. So pretty much the exact same code I showed you before. Add Azure provisioning config, add Azure endpoint, blah, 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 blah. The only difference is I installed this one function, install WinRM certificate for VM. And this is up in GitHub. It's also in my blog. It's pretty much anytime if you just hit this on Bing or something, you can copy this code and put it into a PS1 file or even embed it in your script, and it takes care of all the magic for you. The only thing you do have to remember is when you run this, you have to run elevated in PowerShell because it does manipulate your certificate store. Okay, so entering a remote PowerShell session is nice. I mean, from here I can, I'm on a remote machine. I can do whatever I want with it if I can type. But it'd be even nicer to use something like invoke command to actually execute some code whenever it boots up. So I could do the exact same parameters. And I could also, and what I could do is specify a PowerShell script to run on that remote PowerShell or on that machine. So I have a script here I can run that'll install IS. So now what I'm going to do is it's going to prompt me again for my credentials. And now it's going to actually, instead of logging in and just dumping into a console, it's going to log in and execute that script against the virtual machine. So this is all still a little prompty, so it's not really that automated, but it is possible to get credentials without prompting. You can read it from a text file, you can read it as parameters, and you can really automate the entire thing. I have one of the things that we published in the past few weeks is a script out on GitHub that'll do an entire SharePoint farm deployment. I mean, literally, you specify the parameters, hit F5 in PowerShell ISE, come back 5 hours later and you have a 9-server farm complete with AD and SQL HA. That's kind of the power that's exposed from this. It's kind of an extreme case. I know not everyone's going to write a script to automate an entire SharePoint farm, but you kind of get the idea of what capabilities are here. So in addition to remote PowerShell and all that good stuff, one of the really key facets of using VHDs is the ability to move your disks around. I know that doesn't sound like that big of a deal, but whenever you're talking about moving a terabyte disk or 127 gigabyte OS disk between on-prem and cloud, it starts to get a little bit more important on how you can use optimization here. So from PowerShell, we have two commandlets that allow you to upload a VHD and to download a VHD. They're called Add Azure VHD and Save Azure VHD. And what's really nice about them versus your typical Windows Azure storage tools is they understand the VHD file format. So whenever I call Add Azure VHD, it'll actually, the first thing it does is instead of just treating it like some blob file, it actually cracks up into VHD and discovers what bytes are written inside of that file. So if I have a 127 gig VHD file that has my OS in it, and the OS has only taken 30 gigs, it doesn't upload the other 97 gigs of empty bytes. It really just uploads the bytes that are written on the disk, and the other 97 gigs it just kind of ignores and puts that up in the cloud. So it's a very optimized upload. And same thing for download. We don't download a bunch of empty bytes for you and over the wire. It figures out the file format before it even downloads it. Using these commandlets, you can literally write a script. Just a few lines of code that will take a VHD that's running in your local Hyper-V system and move it straight to the cloud, and it'll boot up just perfectly fine. And the only difference is instead of using -image name and provisioning config, you'd use -disk name and point it to your OS disk. So I'm not going to migrate an entire VM because even optimized uploading 30 gigs does take a little while. So I am going to show you how to upload a VHD though. So you can see our script did work. So we do have IS installed on this machine, installed ASP.NET 4.5 and all kinds of goodness. So what I'm going to do is I'm going to create a VHD, and we're going to upload this out to the cloud. So I'm just going to go to Computer Manager and create a VHD real quick. Put in the location I need. Oops. So a couple of things is, if you want to try this on your own, don't use that. It doesn't work. It works on Windows local. It's all beautiful. It works really great. But Windows Azure only supports VHD right now. So skip the VHDX. The other thing you should avoid is this guy. And, well, I take that back. From PowerShell, you can use either or. And the reason I say that is because PowerShell knows VHD. It'll actually take your dynamic disk and convert it to fixed on upload. If you're using any other tool outside of PowerShell, probably is not going to work unless their tool knows specifically about VHDs. Because Windows Azure only supports VHDs, and it only supports fixed-size disks. The PowerShell commandlets can convert a dynamic to fixed, but they can't convert VHDX to VHD. So a couple of things to remember whenever you're playing around with this. So I'm going to make a 50 meg disk. I'll go ahead and create a volume on it. Okay, and here's our big giant data disk we're going to use to transfer data around. And I always use this to upload my PowerPoint files because it seems to be the most efficient way of uploading PowerPoints to a server. So I'll copy my PowerPoint file over there, detach the disk, and we'll upload it. Okay, so now from PowerShell, I'm going to show the add Azure VHD commandlet. So a lot of code here, but really the general idea is my source VHD, which is basically my data disk, the file I just created that has my PowerPoint file on it. Then I need a destination location, which is a storage count in Windows Azure. This is on the West US coast, so actually this may take a few seconds, copying it across the country. And the add Azure VHD commandlet takes a local file path and a destination file path, and you can pass it a number of uploader threads. So if you have a lot of bandwidth, you can pass it a number of threads, and it'll use those to do this upload asynchronously. And once it's there, all the add Azure disk commandlet does is actually registers that VHD that you uploaded into Windows Azure. So add Azure disk is pretty important though. Whenever you go through the portal or you go through PowerShell and you tell it the disk name, this is where it gets it from, is whatever disk name you specify. It also supports another parameter that's equally important called -OS. So I'm going to upload a data disk, so I won't be able to go through the portal and select that to boot off of. If I did upload a VHD that had an operating system on it, though, I'd want to specify -OS Windows or -OS Linux, whichever one I was uploading. So I'll go ahead and hit F5, upload this. Oops. Fix my typos or whatever I did wrong here. Oh, yeah. Always exit out of your remote PowerShell session before you do stuff. Yeah, the PowerShell commandlets don't run remotely. Or they do, but mine weren't set up for that. Try this again. So you notice at the bottom it detects empty blocks completed. Didn't take too long to do the upload. Took 4 seconds considering it was calculating it. It probably took longer to figure out what was empty than it would have taken to just upload the byte. So 50 megs is probably not the best example for efficiency. So we've uploaded the VHD to the portal. So what I can do now is anytime you're mixing the two, always make sure you refresh the portal because it's probably not up to speed with whatever you just did from the command line. So I can go back to the portal. Of course, you could do this from PowerShell too, but at least want to show the portal a little bit. So I can go to my remote VM1, and I can attach a disk. And here's the data disk we just uploaded. Okay, and let's log into this guy so we can see it when it connects. Okay, so this is our virtual machine that we just attached my data disk to. Oops, not my network. And here's our VHD, already attached. Windows Azure automatically detects that new disk was attached to it, auto-mounts it. So now we have our PowerPoint file. So can use equally creative measures and put another file on here. All right. And all I have to do to download this is I could actually just do save Azure VHD and give it the URL, and I could probably get away with it because it's only a 50 meg data disk that's not getting a lot of writes. However, if you want to do this safely to download a file, you want to detach it first. So I can go to detached disks, Click OK, and what will happen is you can start downloading an OS disk or downloading a data disk that's getting written to, and some X number of percentage in, you're going to start getting these random errors whenever the the Cmdlets are getting things out of sync. Whenever it's downloading files that have been written to, and maybe it has already downloaded bytes that you overwrote. So you always want to make sure that you're downloading VHDs that are not actively in use. So I can use a Save Azure VHD to accomplish basically the same thing. I'm going to reverse my parameters. Instead of the destination being Windows Azure Storage, it's going to be my source. And I'm going to put my destination VHD to be back to the local file system. Same file except dash downloaded. All right, so now I can go in here and see that I successfully downloaded my giant PowerPoint file from PowerShell. It's a little overkill to transfer a PowerPoint file back and forth, but it does get the job done. Now, seriously, of course, this is what you would use to transfer your SQL Server disks up, your whatever VHDs you wanted to use to upload, your OS disks or your data disks. So we can load this guy. Oops, there it goes. Don't click it too fast. And you can see that we were successfully able to use PowerShell to transfer a text file. Very powerful stuff indeed. Okay, so in addition to uploading and downloading VHD files from on-prem to the cloud, you can also use PowerShell to copy stuff between data center regions. So think about it from the perspective of you just built this deployment on the West Coast, and your boss says, hey, you want to move it to the East Coast, or hey, you're in Europe. Maybe you want to get it off the U.S. and move it over to Northern Europe. You can do that without having to download everything to your local machine. Previously, that is how you would do stuff like this. You would download everything to your local machine, then you'd go back and upload it to the other data center. Using PowerShell and the Windows Azure Storage Async Blob Copy API, you can literally tell the storage service, hey, destination, go download this from source. It never touches your machine. It goes from, if we were copying this to Europe, it would go from the destination over to the source and say, hey, VHD, I'm going to start copying you. Never touches your machine at all, and it starts copying it all asynchronously across the internet for you. And the beauty is it is all async. So when I call start Azure Storage Blob Copy, I can do this multiple times. I can start copying 10, 15 VHDs and then go back and pull them later to see if they're done. So when I was in evangelism, I used this quite a bit for TechEd. We'd do everything in TechEd North America. Everything works. We're like, oh, great, the demos didn't fail. Oh, crap, we got to go to Europe. So we'd copy everything and move it all over to Europe. And it would just work. It was amazing. Saved my life numerous times. So let's show you a quick example of how you can do this. So if you ever have to show demos in the United States and then in Europe 3 days later and have to copy over 0.5 terabyte of data, you can do that too. So the first one I'm going to show you is a cheat. So I have two storage accounts. I have MW West US 1 and MW West US 2. You'll just have to take my word for it that they're both in the West Coast. I'm going to pull up a cool tool called Cloud Explorer. This is a really handy tool that's very useful for seeing this stuff. So testcopy1.vhd is a pretty good sized disk. It's 133 gigs. So what I want to do is I'm going to copy it between storage accounts. Any idea how long it'll take to copy between two storage accounts? 10 seconds, 2 seconds, 2 hours, 5 minutes? How long would it take you to copy 133 gigs from laptop to laptop? Probably a few minutes, right? So, again, I'm cheating though. Show you the code. I'm using new Azure Storage Context. I have to get the storage account key to know how to, so the PowerShell Cmdlets have access to write to it. I'm going to create a container, which is kind of a folder in storage terms if it doesn't exist, and I'm going to tell it to go ahead and start copying. And this commandlet at the end just tells you the progress of your copy. So I'll go ahead and hit F5 here. And as you can see, the copy is successful. So I totally cheated. It was instant. I copied 133 gigs like that. Right? It took longer to connect to the internet than it took to actually copy the data. So if I go over to MWSUS2, here's my copied VHDs container. As you can see, I didn't cheat completely. It was just created. And there is our disk. And the reason it did that is because inside of Windows Azure Storage, there's a concept of it called a stamp. So yeah, you might have your multiple storage accounts in the same data center, but they may not be in the same stamp. These two just happen to be in the same stamp. And if they are in the same stamp, it's a shadow copy. It's instant. If you try to create MW copy from WestUS 1 to WestUS 2, it could take 30 minutes. Just depends on whether they're in the same stamp or not. And the only way you can tell is if you ping that storage count versus the other one. If they return back the same IP address, same stamp. If they're in a different stamp, you'll get different IPs. So you can't depend on that behavior. Like I said, I was cheating. Now, if you really want to see the cheat, or a not cheat, a legitimate, I'm going to show you demo number 2. And this is going to be, well, so I was going to copy it to East US. Since we're in Europe, I probably should create a Europe storage account. So using PowerShell, I'll show you how to create a new storage account. So get Azure location. I'm going to use a North Europe data center location. So I'll say new Azure storage account. And sometimes this does take a few seconds because it has to register in DNS and everything. But we're basically going to create a new storage account here. And while that's working, I'll update my script. And see the ramifications of unscripted demo changes. Now I have to wait for storage account to be created. But okay, life is good. So now I have to get the storage account key. And again, without using the crutch of the portal, I can use get Azure storage account, or actually storage key. And I can pass in the name of my storage account. And it will give me the primary and the secondary storage account keys I need to use to copy that. So does anyone think it'll be instant to copy 133 gigs from the West Coast to Europe? All right. So you have little faith in the cloud. No, it's not. That'd be awesome if it was. But so what happened now is, since they're not in the same stamp, we actually queued the copy. So the storage service is now going to start copying at its own leisure. So eventually this will get copied over. And what I can do is, if I want to check the status of it, that blob that was returned, I can run it against the get Azure blob copy state commandlet, and it'll tell me the progress of it. So you could kick off a multiple VHD copy and then have a loop that'll sporadically tell you, or occasionally tell you, the progress. So we'll come back in a little while. It'll actually start, the bytes copied field will actually start getting populated. Okay, so let's talk about access control lists. So this is really new functionality. Literally just, it was the last thing I did before I left the PowerShell team, is to actually ship this feature. So what it really does is allows you to lock down a specific public port. So a good example, and there's lots of customers do this, I've had plenty of customers run into this, is they'll deploy SQL Server on a virtual machine, and then they'll have an application, say it's in a web role or a worker role or Windows Azure website or whatever, and they want to access this. Well, the only way to access SQL is to expose it on a public endpoint. So they open up, say port 1433, and then lo and behold, in their event log, they get SA login failed SA, blah, 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 where people are trying to hack this port because they know exactly what port 1433 is for, so they're trying to guess the SA password and crack this box. And it certainly can happen. If you put a weak password, you will get owned this way. So what an access control list does is allows you to put a rule or a set of rules, up to 50 rules, on a single endpoint that can tell you whether you can let a certain machine IP in, a certain network range, whatever, and you give it a description. It's firewall rules for your virtual machine. So what that allows you to do is, fabricam.com, you let them in on that range, they're all happy, but the guy that's trying to guess your SA password, he's booted out. He's not even going to have access to it. And how you do that, how you configure it, is very much like a virtual machine configuration object. You generate a new Azure ACL config, and you use the set Azure ACL config commandlet to modify it. So this can add a rule or remove a rule or set a rule. So I could add a rule that says, allow this subnet in order 1, and I could pass in multiple rules, obviously different orders. I create all my ACLs, and then I update the endpoint, or I can also set the ACL at endpoint creation. So earlier when I showed add Azure endpoint with port 80, you could specify pass that -ACL parameter in, and it would be locked down. Question? So, couldn't hear you.
Would that be possible to do, or to see the contents from the portal?
They do not have this in the... So the question was, can I see and modify ACLs in the portal? And the answer is not yet. They're working on... it should be in the portal very soon. But right now, the ACLs are only available from PowerShell. At least last I checked. So I left a month ago. They might have fixed it since then. But I don't think they're in there just yet. So we'll check too, though. So let's go through and configure an access control list. Before we do, let's see if our blob has started copying yet. Okay. So you can see that, yes, we have actually started copying. Maybe probably not by the session is over, but sometime today my VHD will be copied. So let's jump into the portal real quick just to see if they have done this yet. I'm almost positive they haven't. So I have a Linux VM here, and they don't have anything yet. Okay, so let's do this from PowerShell. So here's my Linux virtual machine. I'm going to use SSH as an example. So I'm going to go here. First thing I'm going to do is I'm going to use PuTTY to try to connect to this Linux VM. Oops. There it goes. Okay, so I can log in from this VM. And now from this My Remote PS1, I conveniently have PuTTY installed. How does that work out? So I'll log in from the VM in the cloud, and I can do the same thing. One of these I want to kick out. One of these I want to say, you can't log in anymore because I'm going to show how ACLs work. So I will pick my desktop here to be able to SSH in. So the first thing I need to know, though, is I need to know my IP addresses. So I'm going to go to Google, because they have this nifty feature, or they used to. There it is. That'll tell you your current IP address. So I can do that. So the problem is I'm behind a proxy, so I don't know if my next request is going to be this exact same IP address. So this is always a risky demo to see if it works. So what I'm going to do is I'm going to create my rule here. Since I don't know if I'll always be .166, I'm going to go ahead and just make this A/24. So the remote subnet is always in CIDR format. So this, if you're not a networking guru, basically all this does is everything with the network name of 217.124.192 and your host name or your IP address of .0 through 255 will be included in this list. And what I'm going to do is I give it the service name, which I think is right. Let me double check. My Linux service 1A, there's my, yeah, so that's right, and my VM name. So what I'm going to do is, just like I showed in the slide, I'm going to create a new Azure ACL, and I'm going to update the existing SSH endpoint to have that ACL on here. And hopefully, when this is done, and you notice the add rule is permit. So how this works is whenever I add any rules that are permit, by default, everything else is going to be deny. If I added a deny rule here for a specific subnet, everything else is going to be permitted. So that's one thing to keep in mind whenever you're building these rules. Because by default, everything is open. So So once this is turned on, I should be able to SSH in from my laptop, assuming I don't get a funky IP address, but I should have kicked out my poor Windows Azure VM from ever accessing that Linux guy. So let's see if everything still works. So here's my desktop, and I can still connect. That's good. Now, can I connect from here? Yay, see? That's good. If I can't connect, that means I did the right thing. Every time I try this, my worry is it's going to pop up and prompt me, and I won't have any idea what the heck just happened. But it hasn't happened yet, so that's a good feature. So you can. So how you can see the rule is, let me create one more here. So you need to know the service name and a VM name. So I can say get Azure VM. And then I can say get Azure ACL config, and I give it the endpoint name. And this will dump out all the rules that I have there. Okay, so let's jump back to the slides real quick. All right, so designing for scale and availability. I know this is not a scale and availability talk, but there are some really cool features that you can only do from PowerShell today that I always like calling out. Availability sets is not one of them. Availability sets you can do from the portal as well. But it's always good to reiterate what availability sets are. So what availability sets are is any time that you have a set of virtual machines, more than one, that do the exact same thing, you always want to group them in an availability set. So a couple of examples, 2 web servers, 4 web servers, whatever, 2 AD servers, 2 SQL servers, SharePoint servers, et cetera. As long as they're performing identical roles, put them in an availability set. What that does is it tells the Windows Azure Fabric controller to put your virtual machines on separate racks in the data center. If you don't do that, there's a real good chance they're all going to end up on the same rack. And if the power unit or the switch on the rack goes down, you have a single point of failure and you could lose all your virtual machines, whether they're load balanced or not. So use availability sets. This splits them up into multiple physical racks in the data center, so you got data center level availability. The other thing it does is Windows Azure runs on the Windows Server Hyper-V, the hypervisor, so everyone knows you have to patch that guy. It's a Windows machine, you have to patch it. It gets rebooted occasionally. So that means Windows Azure will reboot your virtual machines. So how you avoid downtime is by using availability sets. You group 2 virtual machines in an availability set in Windows Azure Fabric Controller. Whenever they do their own patches, whenever they patch their own host OSs, they don't take them both down at the same time. They do a rolling upgrade of the hosts that are hosting your virtual machines. So this is how you achieve the 99.95% SLA with virtual machines. The second thing is always use load balance, or whenever you have load balance endpoint sets, they can be used with, there's a couple of additional features called health monitors that aren't really that well publicized because they're not available in the portal. So I'll show you a couple of examples about the health monitors, but the general idea is whenever you're developing an application, tie your tiers together via an availability set. An availability set is nothing you have to create, it's just a name. As long as 2 virtual machines all have the availability set name is exactly the same, then they're grouped. That's all it takes. So your SQL servers would be SQL AV set. Your IS servers could be IS AV set. They could call it web server AV, whatever you want to call it, right? It's just a string. And then use load balancing for additional redundancy. So here's a little bit more about using the load balancer probes. Now this is only currently available from PowerShell, but there's 2 different probe types. One of them is TCP probes, and the other one is HTTP probes. TCP is a really good health probe, but it's kind of dumb. It doesn't know anything below the protocol. What it does is it basically polls every 15 seconds. So, if this was a web server, it would poll port 80, your local port, whatever you define. It'd poll it every 15 seconds. Oh, and one thing this is new is whenever you create a load balance endpoint, we actually automatically put in a TCP probe. This is brand new, about 3 weeks ago, and I don't think most people realize it. But the general idea is you create a load balance endpoint. If your virtual machine goes down, the load balancer doesn't send traffic to it. Without that probe, you're still going to send traffic to a dead VM because the load balancer doesn't know it's dead. So this probe will basically look for an ACK. It tries to connect to the socket. If it gets an ACK, then it's good. It doesn't matter if the error was 500 error, it's a 401, it's good. The virtual machine stays up. So it's kind of dumb. If your web server is responding with a 500, it's probably not that great to send to the user, but it sure is better than, the virtual machine is completely off and it's still redirecting traffic to it. And what happens is, if the ACK isn't received, it actually takes that node out of the load balancer. But it does continue polling. So if you reboot the box, it takes it out of the load balancer automatically. Whenever the node comes back up, you don't have to do anything. It just automatically picks up where it left off. So HTTP probes are a little smarter. HTTP probes allow you to specify an actual page that can tell the load balancer the status of your app. So if you're developing, in this case, an ASP.NET app, you could point the load balancer probe to /healthcheck.aspx. This could do absolutely nothing other than return a 200, just, hey, yeah, I'm still here. Or it could actually go off and make sure the database is up, make sure your queues are happy, make sure storage is behaving. It could do whatever the heck you want it to do, honestly. But the benefit here is you still get the same behavior. The load balancer is going to poll your health page every 15 seconds. If it returns anything other than a 200 error, so if it gets a 500 error, it gets a 404 not found, it gets a 400, 401, blah, 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 it's going to boot that node out of the load balancer. So if you accidentally deleted the health check page out of your server, it's going to take that node completely out. So you're not giving back bogus pages to your users. And it does continue polling until it's actually fixed, though. So again, these are very powerful additional things you can do to make sure your server is more highly available. So one thing I will say, though, is my first experience with doing load balance endpoints was with SharePoint. And SharePoint doesn't return a 200 by default. It returns a 401 because everything is authenticated. So I set up SharePoint, did load balance endpoints, and nothing worked. It took me a few minutes to figure out what the heck was going on. So I'll show you how you can discover that and not waste 3 hours trying to troubleshoot load balancing. All right, so I have here, well, let me close some of this stuff. I have 2 web servers, ISWFE 0 and -1, and let me show you the endpoint configuration here. So the get Azure endpoint command basically dumps all the endpoints for your virtual machine off. And the one that I'm really interested in is this one right here, the LB set name web. So I have a load balance endpoint name. The endpoint itself is named web. The load balance endpoint set, which is what's important if you want to group multiple endpoints together, is called LB web. So basically, all endpoints in this cloud service named LB web, assuming they have the same public port, will now be load balanced. This is kind of the trick on how the Windows Azure does the association of these things. But what's really important is these 3 settings here. Probe path, probe port, and probe protocol. Actually, there's a couple more. Probe interval in seconds. It's very configurable, right? What I've done here is I'm having my the load balancer check /home/health check. Basically, all it does is it pings this guy every 15 seconds and says, hey, you still there? You still there? You still there? And I can show you what this looks like, because it is pretty straightforward. It's just returning back a page, and if you look in the headers, it's going to be back in HTTP 200. So this is good enough for the load balancer to be happy. If I put anything other than the 200, if I throw 500, it's going to boot that node out. So if I go to my home page, you can see I did some serious programming here, and I showed you exactly what server is returning back. So this is ISWFE 0. Hit F5 a couple of times, and you'll see I'm getting ISWFE 1. So it is being load balanced. So what we can do is I have that health check code here, and all that code is doing is it's looking in my web config app settings for the active server. So it says if the current server is not in this list, throw a 500 error. Pretty straightforward. It's not a very smart health check, but it allows me to really simple configure which one of my VMs is in the load balance config time. So I can go into my web config, and here's the setting, active server is ISWFE 0 and -1, and I can take out, say, I can take out -1. And I'm using web deploy on these VMs, so I can publish to my virtual machine, and I have a scheduled task to do content synchronization between the two, which is kind of tricky because now I have to wait for content to sync, and then once content synced, I have to wait for the load balancer to detect that I changed it. So this demo, I have to talk for about 30 seconds before it actually works. Hopefully I'm close. So if I go in there and I hit Control F5, so I still have WFE0 and -1 in here, so it's not done yet. So while that's working, let's log into WFE1 and look at the web logs, which is a more accurate depiction of the load balancer. This is how you can troubleshoot why your load balancing is not working whenever you're using probes. So I'm going to go under my IS logs. You can see, actually those are old. There we go. So the load balancer has been checking for a long time, and it gets a 200 error, or 200 OK. So up to now, everything's been hunky-dory. Now if I go down, you can see at the very end, where I made that change, I'm actually throwing a 500 error now. So the 500 error is telling the load balancer, I'm very unhealthy, don't serve me traffic, blah, 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 blah. So now when I go back, I should, in theory, not see 1 anymore. I should only see 0. So now if I want to put that node back, all I have to do, put it back in my list and publish again. And eventually, once that code is back there, it'll start returning a 200, and the load balancer will automatically put the node back in for load balancing. So really simple configuration changes, but you get some really powerful features out of it. So again, it'll take another 45 seconds for all this to synchronize, but ISWFE1 should come back up in the load balancer. Okay, so a few more things I want to talk about before we're done is cloud services. How many of you are using web and worker roles today? A few? Okay. Are you using PowerShell with web and worker roles for deployment or management? All right, did you know you could do that? Awesome, okay, so I'm going to show you even if you didn't know. So here's some of the things you can do with cloud services in Windows Azure PowerShell. Obviously, you can deploy your CS package and your service config files. You don't have to go through Visual Studio. You don't have to upload them to the portal. You can literally have 3 lines of code and upload and create your service. You can deploy to Windows Azure Virtual Networks. You can do that with a portal too, but you can also do it with PowerShell. You can restart, reimage. You can change the role instance count all from a command line, which is kind of cool. You can now disable and enable RDP and diagnostics on the fly. So this is a recent change to the cloud service architecture. Before, whenever if you deploy your cloud service package and you need to RDP into it, if you forgot to do that at deployment time, you literally had to crack up in Visual Studio, make a change, and redeploy it. With some of the recent changes they made in cloud services in SDK 2.0, you can actually turn those on by default, or dynamically, and you can do it from the portal as well. You can change the configuration. You can do upgrades, automatic, manual, or simultaneous. Simultaneous is kind of a new feature. I don't know if everyone's aware of it. But the difference between automatic, manual, and simultaneous is automatic basically says, hey, you have multiple instances. I'm going to take them down a few at a time, do the upgrade, bring them back up. It's a rolling upgrade. Simultaneous, well, one problem with that is it takes a long time to actually do the update. And in a staging dev test environment, you don't really want it a rolling upgrade. You want it as fast as possible, right? Because you're just testing your code. And that's what the simultaneous upgrade does for you. It flattens all the boxes and does it as fast as possible. So it's literally a fraction of the time for updates. So I'm going to show you how you can actually do a cloud services deployment real quick. For those of you that have never done it, all right, and before we get started, let me check my demo and see if I have set WFE1 is back yet. And lo and behold, it is. Woohoo! So, yay. Okay. So let's do a cloud service deployment. So here I have, not this. So I have a regular web and worker role. each set to one instance each because I'm running out of cores. So I'm going to go ahead and package this. And you can package everything from the command line too. Not with PowerShell, just with CSPack. I think hopefully they're moving that to PowerShell someday. But until then, you can use CSPack to automate all of this even. So I'm going to go ahead and take this, package it up, and it should spit out two files, my CS package and my CS config. Now, if I wanted an automated deployment mechanism and an automated upgrade, I could use PowerShell. So from the command line, I can... First thing I need to do is create a new Azure service. Has to be nice and unique, so I'm going to put something else here. And after that, I need to just call new Azure deployment. And it has to match the cloud service name. And then I need to pass my package file and my configuration file. And finally, I need to tell it whether it's going to go into production or staging slot. So 2 lines of code, and I can literally take deploy a cloud service up to Windows Azure. And in addition to new Azure deployment, there's also a set Azure deployment that allows you to do the exact same thing for upgrades. So you can upgrade the package, take your service package and your service config, and tell it whether you want to do an automatic, manual, or simultaneous upgrade. So this will take quite a few minutes, so just because it has to upload and deploy VMs and everything. So that's pretty much it. I think what you just saw, you saw a lot of stuff about virtual machines, so I hope you were here for virtual machines and not wanting to figure out how to automate Windows Azure websites or something. But so it's mostly focused around virtual machines and cloud services. Lots of interesting things about deploying virtual machines and disks and endpoints, all that good stuff. And if you guys, anyone has any questions, feel free to hit me now, or I'll be here a few minutes afterwards. But any questions right now? So the question was, if I needed to automate Windows Azure from managed code, would I call the REST API or PowerShell Cmdlets? Good question, considering right now there is not a supported .NET Client library for the Service Management API. That being said, there is one in the works. I don't know how far out it is, but it will be eventually. There will be a .NET Client library available for the service runtime. Till then, I mean, you can certainly use the PowerShell Cmdlets for automation, but it's really up to you whether you want to take the dependency on PowerShell or not. Lots of people do. There's lots of products at Microsoft that use PowerShell Cmdlets within them. So System Center obviously uses them very heavily. So kind of a tough call, but calling the REST APIs directly is kind of painful because you literally have to build up all the XML and everything. But once a client library comes out, that'll certainly be a lot easier of an option. So, any other questions? All right, thank you very much. Oh, one thing, hold on. You can't leave. Do that. Always forget about this, guys. So please eval the session. So scan the code, or I think you have to scan the code to eval the session here, don't you?